In 9.1, we're going to be using two formulas, mainly, the distance formula and the midpoint formula. If you have 2 points, you can find the distance between them, and you can also find halfway between them using the midpoint formula. The distance formula is this. You're going to go ahead and write that down in your notebook. And the midpoint formula is right here in the middle of the 2 points, and the formula for that is here, and you're going to want to go ahead and write that down in your notebook as well. So do that. So pause the video, write those down, and then I'll show you the examples. So the example gives you these 2 points, negative 7, 0 and 5, 3. This is x1, this is y1, x2, and y2. And it says find the distance between the points and the midpoint. So using the distance formula, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. We'll just go ahead and plug in our points. 5 minus negative 7. So 5 is x2 minus negative 7 is x1 squared plus 3 minus 0 squared, which gives us 12 squared plus 3 squared, still under a square root, 144 plus 9, that'll give us 153, the square root of 153. Then we need to simplify this radical if we can. So when you simplify a radical, you're just finding the prime numbers that make it up. 153 is the same as 3 times 51. 51 is the same as 3 times 17. And then all of these are prime. So because the number 3 shows up twice, we get to take it outside. And our answer will be 3 square root 17 is the distance between those 2 points. Next, we need to find the midpoint. And that equation, once again, is x1 plus x2 over 2, comma y1 plus y2 over 2. We're going to plug in our x1s and our x2, so negative 7 plus 5 divided by 2. Y's are 0 plus 3 divided by 2. Simplify it, which will give us negative 7 plus 5 is negative 2 divided by 2, that's negative 1. 3 over 2 will just leave as 3 halves. So the midpoint between those 2 points is negative 1 comma 3 halves. The next type of problem in this section says write an equation for the perpendicular bisector of the line segment joining these 2 points. So on a graph, picture the points are here, negative 3, 4, and 5, 6. And a perpendicular bisector is a line that bisects this line segment at a 90-degree angle. It cuts it right down the middle, it bisects it. So in order to bisect a line, we need to first know what the midpoint is. So we're going to solve for the midpoint really quick. Again, that's x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So the midpoint here is 1, 5, right about here. So once we have the midpoint, we need to calculate the slope of this line. Because if we're going to find a line that is perpendicular to it, we need to know what this line is so we can find a line that has the opposite slope. So to find the slope, that's back to what we did in a very early section. That's y2 minus y1 over x2 minus x1. That's m, that's the slope. So we're going to have 6 minus 4 over 5 minus negative 3. And the slope is going to be 2 over 8 or 1/4. That's the slope of this line, but we want to know the line perpendicular to it. So like we said, to find perpendicular, you flip it and make it negative. So the slope of the perpendicular line is actually negative 4 over 1, which is just negative 4. Now, to find the slope of the line, or to find the equation of this line that has a slope of negative 4 and goes through the point 1, 5, we're going to use the point slope formula, which is y minus y1 equals m times x minus x1. Once again, this is also just a review. So y minus this point that we know, y minus 5, equals the slope, negative 4 times x minus 1. Negative 4x plus 4 y is equal to negative 4x plus 9. So the equation for the perpendicular bisector of the line is y equals negative 4x plus 9. And this really had 4 steps. The first step was to find the midpoint. That was step number 1. The second step was to find the slope. Step number 2. The third step was to find the perpendicular slope. That's an easy step. And the fourth step is use the perpendicular slope and the point to find the equation of the line. The last type of question in this section is classifying a triangle as scalene, isosceles, or equilateral. So remember, scalene is that all the sides are different. They're all different lengths. Isosceles is 2 sides the same. And equilateral is all the sides the same. So in order to do this, you need to find the distance between each of those sides. So that's going to be using the distance formula like I talked about in the beginning. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And you have to do this for each set of points. So you're going to find it between those two, between these two, and between those 2 points.